Alright, hey, this is Stereo Police back with part 2 of the Yamaha A-1000 integrated amplifier overview, and this one's going to be pretty cool because I am going to do a no bullshit test and determine exactly when the A-1000 kicks in from Class A to Class AB, which should be 10 watts per the specs. And I'm also going to determine it when it's in Class AB mode, how many watts basically you get out of Class A before it goes into before it transitions into Class AB. Because every Class AB amplifier always starts in Class A, at least for a watt or two, or a little bit less maybe, but depending on how much it's biased into Class A, and then transitions over. In auto Class A here, we should get about 10 watts before it transitions over, and I'm going to hook up a scope, and we're going to look at it make the transition and run the numbers and figure out when it happens, and you'll get to see it happen on the scope, which is going to be pretty cool. First, I wanted to just start out with the brochure. This integrated amp was produced in either 83 or 84, 1983 or 84. Super high quality amp. This is the brochure. I'll just go ahead and flip through the pages here, and if you're interested in reading about it, you can just pause. And not sure how well the camera will pick up the text here. But there's a lot of cool features to it, and it really was a pretty, let me zoom in, a pretty high quality. I'd consider it to be a high-end amp for its day, and even by today's standards, I believe. Very, very good design. And so I'm just going to flip through here so that if anyone's interested, they can again pause and read about the amp. This is the brochure. Back when manufacturers actually took the time to make quality handouts and brochures about their equipment. There's the specs. Okay, so let's get right down to business. What I have here, go ahead and pull this off the tripod. Is now I've already verified. By the way, I'm not going to show this on camera, but I have the service manual, and I went through. I checked the idling current, which checked out perfectly. I verified the auto Class A circuitry is working, and it does. I did not look at the X amp. The X amp is basically a power supply that beyond a certain point it increases the rail voltages. It's a pretty common design. Nothing revolutionary there, but I'm not even going to get into that. So what I have is I'm outputting from the audio generator 1 kilohertz, 1K. I'm measuring the voltage across the speaker load right there. Increase it a little bit. Got 8-ohm dummy loads. I've got a fan on them to keep them cool, and this is my input signal. And what we're going to be looking at, okay, I've got my battery powered scope here, which has an auto shut off, and it just shut off. I've got the battery powered scope because I'm taking a differential measurement, not reference to earth ground, across a particular resistor. And that resistor I should be a little bit more organized and have this prepped in advance, but that resistor is a resistor right there that's across, that's at the emitter of, and I could do this on both sides, but it should be the same on both sides. It's an emitter resistor of the final output transistor right here. So this the last thing we see before we hit the speaker load is this emitter resistor. And it's a small one. Gosh, I forget already. What is it? 0.22 ohms, I believe. Don't quote me on that, but it's small. And by probing across that resistor and measuring and looking at the voltage waveform, we're getting a direct reflection of the current that's flowing out of that emitter. So we can see when it's in class A, we should get a sine wave, right? And when it transitions to class B, you should see that classic hump. So in class A, I'm writing with my left hand here. It's going to be kind of hard, but we should get a sine wave. And when it transitions into class B, we should start seeing that classic hump where the output transistor is sharing the current sourcing between one of the output transistors and the other complementary transistor down here. So we should be able to see that. And let's go ahead and start. I'm going to start out in auto class A. Let me get my. I got to adjust this thing. I guess when it turned off, I lost my adjustments. I don't know why. Hang on just a second. Okay, yeah, when my scope turned off, it didn't save my previous adjustments, so I had to redo it. I don't know why. I have to learn more about this little scope. I think there's a little save feature in there. But anyway, so here's our 1K. Right now, I'm going to start out at 0 volts across the load. The volume turned all the way down, and we don't have a waveform across that emitter resistor. Now, as I slowly turn up, okay, there's 0.1 volt, 0.8. Okay, now I'm going to switch back to the scope. As I slowly turn it up, we're looking at the current flowing through one of the two complementary BJTs on the output. Now watch what happens. That's class A right there, right? Boom, popped into class B. Question is, where did it pop in? Let's go right to where it popped in. Right there. We're at 10.3 volts RMS. That's a pretty. Yeah, let's do the numbers for at what power. Of course, 10 times 10 is 100. Divided by 8. 12. Ha. Trying to do things left-handed here. 12.5 watts. So it transitioned into class B at 12.5 watts. Let me back down towards just into class A, and you know, it's not exactly a clean waveform. Let me go to a clean waveform. It's pretty clean right there. Fairly clean. It just starts to get goofy right there. Pretty clean right there. That's 7 volts. 7 times 7 is 49. Divided by 8 is, well, I should know that, 6 watts. But it still stays class A. Again, pop right there. Pop right there. And again, that's 10 volts. So it's about 12 watts class A. Okay, so we're in auto class A. So let me go down to where we're in class A, then turn auto class A off. I'll go down to that 6 volt point right there where we had a good clean class A. I'm about to hit the auto class A switch. Ready? Boom, class B. So now let's find out. I'm going to roll back the voltage to the point where, and I'm turning the volume knob down. It looks like it's class B most of the time. I don't know if I can go any lower in my resolution here. Hang on. 50 millivolts. Okay, that's as low as I can go. So there's a class B signal. I'm going to keep going down. It's somewhat class A right there, but it starts class B right away. I mean, look at the output voltage, 0.8. 0.8 volts, right? I mean, 0.8 times 0.8 equals divided by 8. I mean, that's just a tenth of a watt. So this basically in Class B, it's just barely biased into Class A, just enough to keep those emitters flowing. So it is way into Class B, unless you click the Class A. So let's click Class A again, and boom, nice clean. There's our nice. See, still in Class A, still in Class A. And pop right there, pop. And there's our 10 volts. So guess what, kids? This thing is as it's supposed to be. Yamaha is 100% no bullshit. No BS. You know, you read all these things, you know, from now Yamaha's a reputable corporation, they wouldn't screw around, but you read all these things, you never really know, you know, you read all these things about circuitry and features and all this stuff, but the average person just, you know, you just have to take their word for it. So I just like doing a bullshit check every now and then, and you know, Yamaha being who they are, you could pretty much trust them, but trust but verify. That's what I say. That's a quote from Reagan about the Russians. Okay, so cool. Class B, Class A. Now we're in Class A. Once again, I'm going to turn Class A off, and boom, right into Class B. 100% correct. I dig it. I like it. So there we have it. Really cool little test here. I'm not scoping the output right now, but I did that in the last video. Again, taking a differential measurement with a battery powered scope, got to do that. So hey, that was fun. It's time to get this thing hooked up into my system and give it a listen, and part 3 final will be listening impressions relative to my AS1100 integrated amp that I recently did a video about. That one, for the time being, while I have it, is my reference standard. And so we'll do some comparisons with that regarding sound. But, oh yeah, one other thing I wanted to clarify about the features of this amp. I'm going to go ahead and turn it off, no use in running it anymore. Is I did some more reading about it, and the direct, where was that? I can't see. Oh yeah, the direct button, and I haven't verified it yet. I'm going to do it when I hook it up, but the direct button is not a preamp input. The direct selection on the AS1100 is actually a preamp input. But here the direct bypasses all tone controls and all filters. So I think if I read the owner's manual right, no matter what your source is, when you click direct, that source will bypass all of the tone controls. So the kind of cool thing about that is, and they mention this in the manual, is you can set your tone controls to where you want them, put your filters on, do what you need, but at an instant you can go back to a baseline of nothing with a direct if you need to, for whatever reason. And I think that's the only thing I got wrong before, when I was in part 1. So yeah, I think that was about it. I thought there was something else I wanted to say, but I forgot. Okay. So look forward to part 3, listening impressions, and we'll go from there. Ciao.